Hello students. This is me Malloy, and I will be taking your classes on this platform actually, because we were facing some problems in the Hangout that the number of maximum people that can be joining is less actually. So I am searching for other platforms. We will be having some discussion classes over there, but I'm making these videos for you guys to actually go back and forth wherever you are having some difficulties, that you can actually call me and ask, and you will be able to pause and again see it to make it very clear for you. Okay, as we have we all are inside our houses, we are not being able to discuss anything in person, so that is why I am making these videos. After that I will be taking the webinar sessions also, for which we can be able to discuss. Okay, the today's topic is electric dipoles, as we have earlier discussed that we will be dealing with it. Okay, so now we know about electric fields, we know about the electrostatic force. So electric dipole is a new term that we haven't learned yet. Okay, so now electric dipoles, this word means there has to be two things here. There are two charges actually, two opposite charges separated by a distance, say let it be d for now. Okay, so dipole means two opposite charges which are being balanced in the minimum possible distance. Why they are called dipoles? Because they become a pair. They become a pair. Pair means if these two are here, and if I apply a force in this direction, then it also will be moving in this direction. Means they will be performing like couples that we have already studied in our mechanics. Couples in case of mechanics, and this electrostatics, electric dipoles are more or less the same things. Okay, uh, now the minimum distance if we are having, and they are apart from each other, and if we apply a force in one of the charges, and if the other charge will be having the same experience of the force, then we can say this is a dipole pair. Okay, now there are some very important points that we have to be looking after, like dipole field. This is very important. We know about electric field, this is the same, we will be discussing the electric field here. But when we are having two charges, means what? The For positive charge we know it is always outward, and for negative charge it is inward, na? We know about the electric fields. But if we are having a pair which is very closely situated, so we will have something, say, like this. These are similar like magnetic lines of forces. Okay, you will be having some experiments in your physics lab also. So this thing actually, if it is a three-dimensional view, we will have a cylindrical symmetry for it. It is very important to remember that this structure is actually of a cylinder, because if we can have a field here and here, so this is the polar regions in case of magnets that we have. So the main thing, if the distance is very small, most of the electric lines, they will tend to be in this direction, and few of them are going across, going over. Okay, so this region, it is a cylindrical in shape. Okay, uh, now uh, about this part, about the dipoles, uh, this d distance that we are being taking, there is another term for it. It is actually dipole moment. Means what? How the dipoles are being experiencing the force. This can be defined by this term that is called dipole moment. Okay, now as we know, for the masses itself in mechanics, they have the moment. Okay, the moment of forces, the force into the displacement, we get the moment of the force. Then we are here, we are having the moment of the charge itself, and it is known to be as dipole moment. Okay, now what is the definition for it? As the symbol signifies, this is the dipole moment. This is equal to q into the distance between them. Q is the amount of charge. We're not having the total charge, we're having just a single charge. It is like moment of a single charge particle is will be equal to the moment of the other particle. So that is why this is the single charge and multiplied with the distance, then the unit will become coulomb meter. Okay, now this distance in the in many books, this distance is taken to be from the midpoint of the separation. Say this is L, say this is L, so the distance it is actually 2L, so this becomes Q into 2L. Okay, now there is another term that is called ideal dipoles. What are they? If this distance is tending to 0, means these charges they are being placed very near to each other, then they will behave like a single pair more consistently, and they will behave like a point charge particle itself. That is known to be as ideal dipole. Okay, now uh, in case of these dipoles, there are several things that we will be calculating after this. This is the basic concept, and I am creating this video just for a demo purpose to see what is the response from the students. But the thing is that in case of dipoles, we will be able to calculate electric fields in different positions, which are very important for your boards as well as JEE question papers. Okay, like say it is the axis. So this axial plane or this axis itself, on this axis, if we consider a point here or here, so we can be able to calculate the electric field at this point. Or say if it is the equatorial plane, if we consider a point here, so we can actually calculate the electric field here also. Otherwise, what we can have any arbitrary point, and we can be able to calculate electric field at this point also. So these will be the next topics for us. For now, what we can discuss, that is the dipoles present in nature. Where can we find the dipoles? There are some permanent dipoles. As we know that water molecules, their structure is a kind of like this. I don't know much about chemistries, but this kind of structures are there. So they actually form dipoles in their own construction. Chloroform is there. So those particle natures, the bonding pairs, they behave like dipoles itself. Okay, so this is it for today. This topic is very crisp and very basic. This is the description or the introduction for the electric dipoles. We will be going deep inside of this topic and we'll be solving several problems from it. Okay, for now it is it. uh, thank you for watching, and please don't don't forget to hit the bell icon itself. I will be uh, posting several videos of it for different topics of electrostatics as well like electrodynamics in the next parts. So please share it, comment. If any feedback is there, then that will be helpful for me. Please, thank you very much.